For this problem on the topic of kinematics, we are told that a diver dives from a 4-meter high diving board and strikes the water at a time of 1.3 seconds later. The diver strikes the water at a distance of 3 meters beyond the end of the board. If we consider the diver to be a particle, we want to find her initial velocity, her maximum height reached, as well as her final velocity when she enters the water. Now we'll choose the origin to be the water level directly underneath the diver when she left the board. We'll choose upward to be the positive y direction. For the diver, y0 is equal to 4 meters, and the final position y is equal to 0. The acceleration ay is minus g, and the time of flight t is 1.3 seconds. The horizontal displacement of the diver, delta x, is 3 meters. Now the horizontal velocity is determined from the horizontal motion at constant velocity. So delta x is equal to the constant speed in the x direction vx times t. And so vx is equal to delta x over t, which is a horizontal distance of 3 meters over a time of 1.3 seconds, which means that you traveled with a horizontal speed of 2.308 meters per second. Now we can use a kinematic equation to find the initial y velocity. We'll use y is equal to y0 plus v0 y times t plus a half ay times t squared. So the final y position is 0. This is equal to the initial height of 4 meters plus v0 y times a time of 1.3 seconds plus a half into the acceleration g, which is minus 9.8 meters per square second, times a time of 1.3 seconds squared, which means we can rearrange and find the initial y component of her speed, which is 3.293 meters per second. So the magnitude and direction of her initial velocity are firstly v0 is equal to the square root of vx squared plus v0 y squared, which is the square root of 2.308 meters per second squared plus 3.293 meters per second squared. So this gives us her initial velocity to have a magnitude of 4 meters per second. The angle at which she leaves the diving board, theta, is equal to the arctan of her initial y component of velocity over her x component of velocity. This is the arctan of 3.293 meters per second over 2.308 meters per second, which gives us an angle of 55 degrees above the horizontal. So that gives us her total initial velocity. Next, for part B, we want to find the maximum height that she will reach. Now the maximum height will be reached when Vy is equal to 0. So using the equation Vy squared is equal to V0 y squared plus 2a delta y. Our final speed is 0. Our initial speed in the y direction is 3.293 meters per second squared plus 2 into her acceleration, which is due to gravity, minus 9.8 meters per square second times her maximum height, y max, minus her initial height, 4 meters. So if we rearrange this equation, we solve for her maximum height, y max, to be 4.6 meters. And lastly, for part C, we want to find the velocity Vf with which she enters the water. Now, to find the velocity when she enters the water, the horizontal velocity is constant. Vx is equal to 2.308 meters per second, and the vertical velocity can be found from a kinematic equation. Vy is equal to v naught y plus at. And this is equal to her initial speed, 3.293 meters per second in the vertical direction, plus acceleration minus 9.8 meters per square second times a time of 1.3 seconds. So we get her final speed in the y direction to be minus 9.447 meters per second. The negative sign means that she's moving downwards. And so therefore, the magnitude of her final velocity v is the square root of vx squared plus vy squared. This is the square root of 2.308 meters per second squared plus minus 9.447 meters per second squared. So the magnitude of her final velocity is 9.7 meters per second. And she enters the water at an angle theta, where theta is the arctan of the final component of velocity, Vy, which is minus 9.447 over Vx, which is 2.308, which gives us the angle of minus 76 degrees, which is below the horizontal.